And we are back. We're continuing on Chapter 8, Section 4, Trigonometry, but this time we're going a little bit deeper, doing some different things with our trigonometric functions, sine, cosine, tangent. So this is Part B of the same section. Okay, so we have functions sine, cosine, tangent. So far we have learned how to create the create the ratio sine, the ratio cosine, the ratio tangent within a right triangle when we are given the two or three sides of that triangle. Set up the fraction, turn it into a decimal. And we learned how to find that decimal if we were just given an angle measure and not the sides. We can also go backwards using what's called inverse function. The word inverse pretty much means backwards or opposite. So this time, if you know the decimal value, you can find the angle measure. In the last video, we had the angle measure. We punched it into the calculator and found the decimal. This time we're going backwards using what's called the inverse function on your calculator. Every calculator is different, so I'm telling you the procedure for using the TI are 83 and 84. Many other calculators are similar. Scientific calculators, same thing. They don't have to be a graphing calculator. But let's say you know that the cosine of an angle, again, it's important to note the function that you're using. You have to know, is it sine, cosine, or tangent? And you have to have your 4-digit decimal. Okay. We represent our unknown angle with a Greek letter called a theta. So this is what the theta looks like. So to write these words into an equation, we would say cosine of theta, our unknown angle, equals 0.7071. What is this unknown angle? How many degrees is this angle that we are taking the cosine of? Well, on the TI 83 and 84, you're going to hit that yellow button at the top left, the second button. If you look at your cosine button, you notice that it says cosine -1 up at the top. That -1 as an exponent means inverse. But in order to use that function, you have to hit the second button. That's why it's in yellow. So we're going to hit the second button, then our cosine button, then we push in our decimal value, 4 digits, 0.7071, enter, and you will get how many degrees that angle is. Again, before you start using your trig functions on your calculator, you need to make sure that you are in degree mode if you want your answers to be in degrees. And for my class, that is what we're doing at this time. So if you need to check your mode, hit your mode button, go down to the third line and make sure that degrees is highlighted and not radians. So if your cosine value is 0.7071, then you are at a 45-degree angle, is what this is saying. So again, this is the procedure for the graphing calculators we use in my classroom that many people have. All calculators are different, so you're going to look for the button that has that -1 on it over your sine, cosine, and tangent. When all else fails, get out your manual. Okay, so let's do some examples of finding the angle for the given function value. So you have to know your function, you have to know its value, use your inverse button to find the angle. So if I said, what angle has the cosine value of 1? How are you going to punch that in? You're going to, again, use your second button. Then you're going to hit your cosine because we're using the cosine. Then you punch in the number value. And then you hit enter. If you're in degree mode, you would get the value of 0 degrees. And that is possible. 0 is a number just like anything else. So don't worry about that. So that means that this angle of our triangle was 0 degrees. What if I said the sine value of an angle is 1/2? Well, if I gave you the fraction 1/2, first of all, you would need to change that into a decimal. So we're going to divide 1 by 2 and get 0.5. You got to know the decimal value. You can punch in fractions in your calculator if you want to go through all that. And you know how. So then we'd push second. I said sine value, so you're going to put sine 0.5, 0, 0, 0, enter, and you should get 30 degrees. Tangent of an unknown angle is 1.7321. Practice punching that in and see if you get 60 degrees. So the only difference is we're hitting the second button from what we did in the last video. Second, because we're doing the inverse or the opposite function. So what you need to know is if you're looking for the function value, if I want to know what is, if I want to know what is cosine of 45, you don't use the second button here. No second button. But if you're given the function value and you want to find the angle, measure. So it gives you sine of some unknown equals 0.5. You're looking for the angle. Then that's when you use your second button. So you're going to have to take a little bit of time to practice and get familiar with these things and know when to use the second button and when not to. You're going to have to study a little bit, think a little bit. It's good for you. Now we can use all of these different relationships to find missing side lengths. So we just found out how to find the missing angle. We can use the same relationship, sine, cosine, tangent, to find missing side lengths. And it takes, a process, a strategy. First of all, you need to know which trig function are you going to use. Well, in order to know which trig function to use, you need to know, do you have opposite and hypotenuse? Do you have adjacent and hypotenuse? Or do you have opposite and adjacent given to you? And when I say given to you, I mean, marked on your triangle with either a number value or a variable, ABC. Once you decide on the trig function you're going to use, you're going to plug in the known values into your formula. Remember SOHCAHTOA. Okay, so you're going to use these definitions to create your fraction, plug in what's given to you in your triangle. You will have one unknown. So you're going to solve for that variable. A lot of times you have to cross multiply. Calculate and get your answer. Okay, so let's do an example here using this strategy. So here's SOHCAHTOA. All right, so I have an angle here. Standing at this angle given to me, if I want to find x, which is what we're being told to find, I got to decide, is this x opposite, adjacent, or hypotenuse? Which is it? It's the opposite. I hope you got that right. I can't have two variables in the same equation and solve for an actual number if I only have one equation. So I don't want to think about this y right now. If I'm asked to solve for x, this is the only unknown I can have. So that way I need to consider this 10, and which part of the triangle is the 10? Is it the opposite, the adjacent, or the hypotenuse? You should know it's the hypotenuse. So these are my two parts, opposite and hypotenuse, O and H. Which one of my trig functions have O and H in them? Sine. So I'm going to write that definition down. Sine equals opposite over hypotenuse. Now I substitute in what was told to me. Sine of what angle? Well, I have a 32-degree angle in here, so I'm going to put that in my equation. Sine of 32 is going to equal the opposite side, which was x, over the hypotenuse, which was 10. I am literally taking this formula and replacing the parts with what's given to me in my triangle. Okay, now you can always make a fraction out of something. If you don't know how to solve for x here, whether to multiply or divide, put it over 1 and cross multiply. So then you have 10 times sine of 32 degrees equals 1 times x. Well, 1 times x is just x. So we would rewrite it as 10 times sine of 32 equals x. Now I need to know the value of this. How do I find the value of a function and an angle? Remember, this is the one everybody forgets because it's so easy. You literally punch in sine 32, enter on your calculator. And for sine of 32, you get 0.5299. Now, if I multiply that by this 10 out here, I just move my decimal, and I get about 5.299. Because we've rounded, it's an approximation. It's not an actual value. So that's what this squiggly equal sign means, about. Let's do another one. Same triangle. We're going to solve for y this time. So we have the same angle, but because we have a different side, we have to use a different function. Which side is this? Opposite, adjacent, or hypotenuse? It's the adjacent side. Then we find a side that has a number on it. Identify it, this time as the hypotenuse. Go to SOHCAHTOA. If we have adjacent and hypotenuse, we're going to use cosine. So write that definition down as a fraction and plug in the actual values that are on your triangle. Cosine of what angle? What's our angle measure here? 32. What was our adjacent? Y. What is our hypotenuse? 10. Plug them in. Again, make a proportion if you need to remember whether to multiply or divide. So I'm going to multiply 10 times the cosine of 32. Multiply 1 times y, and again, it's just y. Punch in cosine of 32 in your calculator. Cosine 32, enter, and you get 0.8480. 0.8480. Again, if you're not getting that number, it could be because you're in radian mode and not degrees. When I multiply by 10, I'm literally just moving that decimal point over one space. So my final answer is 8.48. Again, that is approximation. So we use our squiggly equal sign. Not going to count off for that detail, just know what that means. Okay, here's another example. We're solving for x. So try to set this up before I do. Pause the video and try to solve it. Do some thinking, do some work on your own, and see if you can do this. I have to identify the function. Well, if I'm solving for x, what side is x? It's the opposite side. The only known side is this 3. What is the 3 with respect to that angle 27? Is it opposite, adjacent, or hypotenuse? It is the adjacent. So I have opposite, adjacent. What function is that? That is tangent. Write your definition. Fill in the parts. My degree is 27. Opposite is x. Adjacent is 3. Make a proportion if you need to. So 3 times the tangent of 27 is x. What is the tangent of 27? I punch in 10 to 7, enter, and I get 0.5095. I got to multiply that by 3. So let me write that in here so you'll know where that came from. 0.5095. When I multiply that by 3, I get 1.5286. About, since I rounded. Now we're going to use the same triangle, this time solve for y. So I need to identify which side is this y. It is the hypotenuse. Still have the same given side, which we said was adjacent. What function uses adjacent and hypotenuse? Hopefully you're starting to say this quickly, not having to look at SOHCAHTOA. Plug in the known values. I need to put my 27 with my cosine. Adjacent is 3, hypotenuse is y. Okay. So again, we're going to put that over 1. I actually did this in the animation this time. When I cross multiply, my y goes with my cosine. And 1 times 3 is 3. So to solve for y, I would need to divide by this cosine of 27. I got to do that to the other side. Okay, so your algebra skills, you still need to know them. Whoops, that's a 7. Can't ever let go of those. So y equals 3 divided by cosine of 27. So cosine of 27 is 0.8910. So you're going to punch in 3 divided by, and you can punch it straight in like this. You don't have to find this decimal first. You can just say 3 divided by cosine 27 equals 3 divided by cosine 27, enter, and you get 3.36. When you round, it rounds to 70 instead of 69. It's 697. Okay, here's another one. What function are we going to use? Opposite and adjacent. Tangent. Plug in your values. Make a fraction out of it if you need to. Cross multiply. Are we going to multiply or divide to find x? We have to divide by tangent of 58. Punch it in your calculator, or you can find your decimal first. Either way, you should get 7.4986. Okay, now we're going to go the opposite direction. We can't forget how to use our techniques. We don't know our angle this time, but look, we still know what sides we're using. We're still using opposite and adjacent, which we just said was tangent. So we're going to use the same formula and plug in the parts we know. We don't know this angle value, so we're going to put that Greek letter theta there, remember? But we plug in what we know. Always just plug in what you know and then work it from there. Our opposite is 12, our adjacent is 9. 12 goes on top, 9 goes on bottom. Now we got to find the decimal value here. We got to divide. 12 divided by 9, I should get a number bigger than 1 if I think that through. Now think back to the last video. What do I have to do to find this missing angle if I know the function and its value? Remember, this is where you use your inverse function. You're going to push that button that has that little -1 exponent on it. So we have to use your second button. So you would punch in second tangent 1.3333, enter, and you get 53. 53 what? Well, it's an angle. Remember, theta is an angle, so 53 degrees. So that means that this angle right here is 53 degrees. If these two sides have the ratio of 9 to 12, 3 to 4, 12 to 9, 4 to 3, it's going to be a 53-degree angle. Okay, so you need to be able to use your functions and your inverse function to find missing sides or missing angles. Okay, we'll practice more in class. Good luck.